Hi, we made it to the end of the day. Shout out to everyone that's still here. The last two people have done a great job sort of illustrating how ZK is becoming more accessible, more performant, and sort of the use case. And with my talk, I want to sort of dive in more of where are these systems being deployed today, and what are some real applications we can point at that are deployed. Quick introduction. My name's Jacob Everly. I'm the product lead for Boundless. Boundless, we'll talk about it a little bit later in this talk, but it's the universal ZK protocol that allows us to bring ZK to all chains. ZK can retrofit and make any chain balanced in execution, and that's what we're all about. Some people have recently touched on this, but let's look and understand why ZK is so good for scaling blockchains. Today in a blockchain, if we want to do verifiable execution, we ask everyone to run the same execution, and then we all compare notes, and we call this consensus. And then once a certain amount of people, see the same thing, we sort of say that's finalized, and that's the state. With ZK, we no longer need this. We get this very succinct, verifiable proof that anyone can verify within microseconds, that anyone has done that execution correctly, so we don't have to redo it anymore. This sort of shifts the paradigm to where a blockchain can only go as fast as its slowest node. It's a single computer. With ZK, more nodes, more power. I can consistently throw more GPUs, and the system becomes more and more powerful, and we sort of get this balanced execution property. And when we look at what are we actually replacing, ZK cannot replace all known execution today. You still have to use the settlement layer to transfer assets, to do storage reads and whatnot, but we can replace a lot of it. I'm looking at two very popular transaction types here, but if you look at the median case, you can sort of replace 70% of execution that's on-chain today, go much faster for much cheaper. So let's look at an example. We're helping Lido with a piece of their protocol. Lido is quite complicated, but I want to talk about the top right here, which is the accounting oracle. The accounting oracle does a few things. It tracks the number of validators currently in Lido. It tracks the balance of the validators, and then also tracks are new people coming in or old people exiting. And currently they have to use an oracle. So they can use a large stake, oracles can compare, because the calculation is just too expensive to do on-chain today. But that's where we come in. We have a very nice library. It's called Steel. The last people, they sort of chatted about using Rust. We want to support many languages outside of Rust as well. So now you can actually just use Solidity in ZK, right? It's Solidity and just generate ZKPs. And this allows us to do much, much larger computations. Working with EigenLayer, they're doing proofs that are billions of EVM gas, and we can go much larger. We were talking with a client the other day, and we generated a proof that would be half of the execution Ethereum does in a single day. You can also do much more expressive things, right? So with Steel, you can do calculations over data and events over multiple ranges of blocks. Currently, if I need to access a smart contract on a rollup or ETH-L1, I sort of have to choose a single block, single information, and it's a single transaction. Now I can do dollar cost averages over a range of 50 to 100 blocks. Additionally, on Ethereum, validators throw away the history of blocks every 24 hours. It's a few epochs. With Steel, actually, you can look all the way back to the merge using a nice feature we call chain verifier. So now we can do this boundless set of execution. We can look at the whole history of Ethereum, so we can do much more expressive things. And we can do calculations across multiple blocks. And other people are using it, right? So I'm sure some of us have heard of EigenLayer. EigenLayer has this thing called slashing. And this is how they sort of penalize operators for misbehaving in the AVS. Well, to do this calculation and see, one, how much a validator should be rewarded, and if they've misbehaved, they have to do a very large thing. They have to do a calculation that is worth billions of EVM gas. But now they can. You can't do that on any blockchain, but they use our ZKVM, they use Solidity. They generate this proof. It's not even really near the limits of today. and they can do it in an economical sense. Next is you're going to start seeing people do much more expressive things, not just on a single blockchain, but across multiple blockchains. So if we can ingest a verifiable block hash, we can start doing things. So Malda is doing a really cool thing. They allow you to lend your assets without ever moving them. For example, let's say I have ETH on Base, and then I want to borrow ETH on Ethereum L1. They can generate a proof that you have these assets, and you never have to move them. They can also then constantly generate proofs to make sure your position remains solvent. So now you can do positions, not just ETH between two chains, because that's what trivial, but you can start bundling assets across multiple chains without ever having to move them. But we're still working on this. It works today, but we never want to stop there. So we want to make it easier. And there's still a few problems that ZK is riddled with today. One is if you want to go to production and generate proofs, you're normally reliant on single parties. You need to go to a single person, do a handshake deal for your proving. It can still be too expensive. There's people that, again, want to do 1,000 times the computation that EigenLayer is doing. We need to make it cheaper. Going to production, the deployment times can be very long. We found that people were repeating building the same infrastructure like verifiers, aggregation layers, and prover networks. We want to abstract that away. We invented the RISC-V ZKVM, and it was really great. You went from writing circuits to writing Rust to generate ZKPs. But we really want to make it to where you write Rust and you deploy ZK applications. And to the last point, Ethereum has a quite nice foundation for ZK, but other ecosystems like Bitcoin and Solana don't. In Boundless, we want to be the best place to deploy your ZK application, regardless of your chain that you want to deploy on. So Boundless is the universal ZK protocol that fixes all of this. And it's really these three main components. So we have one party, L1s, protocols, app developers. Another one, we sort of have like a set of provers that generate the proofs. And then we have this middle component, the market, which is really a conduit to connect these parties in a decentralized, permissionless manner. First, for protocol development. The promise of Boundless is the best verifiable execution environment today and in the future. I want you to have the guarantee not only do we have the fastest systems today, but then as you develop and we grow together and we expand and bring the pie, that we're going to support the newest and greatest ZKVMs or proof systems all the time. So Boundless is ZKVM agnostic. We're going to start supporting the RISC-0 ZKVM, but the RISC-0 ZKVM is not the best for all applications. It's really good at proving ETH blocks and doing these very large computations, but it's not the best for client-side proving. Imagine you want to do a privacy app for payments. You need client-side proving, and you're going to want to use a different ZKVM. Additionally, different proof systems are better for different use cases. So we're working on Binius right now, which will be very fast. It will be a 30x speedup compared to what we have today. But again, it'll be really good for very large proofs. If I want to use something to do client-side, I think like the Lita ZKVM is a great option for you. And we want to support you, regardless of what use case you want to do. Additionally, we support Rust, we support Solidity now, but we want to support many virtual machines. You as a developer have many different reasons to choose a different development environment. If it comes from the support of that ecosystem that you have, if it's certain security properties, if it's something familiar to you, and we want to support them all. We're going to support the EVM, the Solana virtual machine, the Move virtual machine, the Bitcoin virtual machine, and other alternative VMs. And we're also working on support for other high-level programming languages. Next is we give you the best proofreading properties for a proof market. And what do I mean by a proof market? Is you're an application, you show up to, currently you have to ask for these single parties to do these proofs. I just want you to show up and request in a market, and the proof get delivered. You've probably heard of prover networks going around, and prover networks currently, they have certain mechanisms that give you strong guarantees that a proof is generated. We want to go one step farther. When you use Boundless, we give you a guarantee that your proof is delivered to your application, meaning you don't need to go grab it from a prover network, meaning that you don't have to introduce additional single trusted parties. The prover does not get paid until they deliver it to your application, so it's one less thing you have to worry about and one less thing you have to do. There's no single points of failure. If you fail to deliver a proof to a rollup today, there's a liveness issue, and that's very bad, but it's not the end of the world. The chain halts and it will get back up. But when we look at use cases like Mendy or Eigenlayer, if the proof doesn't show up, the funds are at risk. And if you don't have a decentralized protocol and you have trusted parties and you have multi-sigs that protect things, that just doesn't fly with them. So from day one, once Boundless goes to mainnet, it'll be fully decentralized. You know, RISC-0 is the main devco right now. If RISC-0 ceases to exist on day 2, the protocol will continue on. Additionally, with the market, we're going to make sure you get the best price. We use the best on-chain price discovery mechanism. We just use a reverse Dutch to make sure that you're getting the best price from the prover. Additionally, you can have the best latency. We can make sure that a well-formed request is accepted in the next block. So if you're using a fast blockchain, that can be as fast as 200 milliseconds. And additionally, there's no redundant work. Comparing to other ZK systems where they require provers to race, which creates redundant and wasted work, we require people to lock in the request, which drives down the price farther for your application. And lastly is proof sovereignty. We don't require you to come to a new network. We don't require you to come to a new chain. We don't require you to use a new bridge. We can deploy Boundless on your network, allowing ZK applications to deploy, and making sure that you aren't reliant on other blockchains. And lastly is we want to work with the best sophisticated prover set to give you the best quality of service. So we're on testnet right now on Sepolia, and we already have 10 to 15 prover parties that are incredibly sophisticated. They're securing mining billions per year already and producing proofs on our network. Additionally, these parties have experience in bringing accelerated hardware to market. I didn't touch on this before, but currently we just use AWS for proving, and AWS is very expensive. Once we go to mainnet with market, you'll probably see close to a magnitude in reduction in cost because on-prem hardware is that much cheaper. With accelerated hardware, like an FPGA or an ASIC, we're seeing some early tests, you could see another magnitude on top of that in reduction in cost. And lastly is we want to have an open prover set for 2 reasons. One is liveness. The whole time, Boundless operates with a one-of-n trust assumption. So we assume only one party needs to be online to keep your protocol keep going forward. And lastly is I'm a big believer in open markets for innovation. We cannot tell people that they are only going to get X amount of price. I want to have the incentive for someone to innovate and capture that, resulting in the price of proofs going down. So a summary of Boundless and sort of the features is we get industrial strength from day 1. We're ready to secure billions. Once we go live with this, you get the most efficient market to get the cheapest proofs. We have the best price discovery mechanism, and we have the best latency possible. Lastly is you as a developer don't need to compromise on your virtual machine. It's the best development environment based on your preferences and your use cases. Thank you for listening. I forgot to put one slide, but we're going to go to mainnet with real funds in Q2 this year. So it's not a white paper I'm talking about. It's not some numbers I'm throwing up on a screen. It's real and it's now, and it's ready to be developed on today. So thank you, guys.